Let's continue with boring and boring machines. Boring is a hole making process actually, or we can say that it's hole enlarging process. Hence, we can start the boring with an available hole and then later try to increase its dimensional accuracy or increase the size of that hole. And in order to do this boring operation, we need to have cutting tools installed on boring bars. Usually this is a boring bar, and at the tip of that boring bar we have kind of inserts very similar to the ones we are using other machining operations like turning, milling. And another thing is that since this boring bar is quite longer, in order to actually remove any problems related with vibration, chatter, we need to have some kind of tools to increase stiffness of our tools. For instance, we may be using some alloy discs, or we may have some special materials inside your boring bar so that the vibration will be decreased and the stiffness will be improved. And we can do this boring operations on the lathe machines. We need to simply mount our boring parts into the tailstock and then do the boring. But if the part is, if your workpiece is quite large, then it's better you consider doing this boring operation on a separate boring machine. And we have two types of boring machines. The first one is horizontal boring mills, and the other one is vertical boring mills. The second one is much frequently used, but their fundamentals are the same. They have a kind of a table, and in the horizontal boring mill, actually very similar to our lathe, our actually cutting tool is moving in the horizontal direction and going into the workpiece and doing the boring operation. But in the vertical boring mills, that's a bit different. We have our workpiece mounted on a table. This is rotating at, again, very high speeds, and then we have such a cutting tool moving in this vertical plane and only in x-axis. So these are the main difference between the horizontal and vertical boring mills. Now I will jump to drilling operations. We said at the beginning this chapter is about turning and some hole making operations. Drilling is one of the main hole making operations. The operation is called as drilling. The tools we are using in the drilling operation is called as drills, and the machines are simply called as drilling machines. And we know that hole making is quite important, especially you are doing some assembly operation. If you want to join two parts together, then probably you need to have a kind of a hole in maybe one of them or in both of them, and then later put some other components inside and join these parts together. And the easiest approach to open holes is actually drilling. So that's why we have many types of drills, types of tools, and some other types of machines under this drilling operation. And I will start with discussing the types of cutting tools we are using in drilling operation. As I said, the tools are simply called as drills, and usually they have high length to diameter ratios. Okay, assume that this is your drill, this is your cutting tool. As you see, its length is very high compared to its diameter, and that's why actually it's quite difficult to have stable drills during the operation, since they are longer, their diameter is not too much, they are quite flexible and can easily be broken, or you may have some cracks on the surface, and these will actually result in inaccurate holes. So that's why actually after the drilling operation we perform other operations to increase the quality of our surfaces. Another issue about the drilling is that for most of the time the size of the hole is quite larger than the size of the drill, so that we can easily remove our tool, our drill, throughout this hole. And this has actually several reasons. First of all, since we have high friction due to heat generated, again, we will have high temperatures around the hole, and the workpiece will actually enlarge due to the high temperature. And then once it's cooled down, obviously its diameter will be decreased a little bit, and that's why at the beginning we can remove it a bit easier, since the size of the hole is a bit larger than the size of our cutting tool. Another reason If it's a brittle material, the brittle workpiece, then probably we have removed too much material from the surface of it. And there might be several reasons for this. Other reason is that if your cutting tool is not stable, it's vibrating, then probably again it's removing more material from the surface of your hole. And due to these reasons, as I said, the diameter of the holes actually we are machining are usually larger than the diameter of the drill. And that's a nice issue since we can easily remove it from the opened hole. Here you see a typical drill. This is our drill, as you see, and this is probably a twist drill, the most popular type of drills. And I will now discuss some parts of it. Let me start annotation here. So we have first the shank part. This part is actually going into the tool holder. This might be tapered, like having such conical surface, or it might be straight. We put it into the tool holder and then fix it by using some other mechanical equipment. And then after it, our body starts. This body is main body responsible for removing material from the hole. And as you see, we have some angles and we have some cutting edges always at the tip, but let me first focus on these flutes. Flutes are highly important, these openings. And usually cutting tools, drills actually have 2 or 3 flutes, and they are mainly used to remove actually chips generated in this hole. Since the hole is actually a kind of a closed region, we cannot easily remove the chips from the holes. And these flutes are actually helping us to remove the chips generated here. For instance, it will follow this path and then go outside this tool. Otherwise, we will not be able to remove the chips, and that will probably be embedded into the workpiece once again, and we will not be able to open the hole. And let's clear once again. And this is the flute length, the whole body, as I said, the overall length. And we have a helix angle. This is one of the important angles of drills. It's actually referring to the angle of these flutes, angle of the chips moving in this flutes. And then we have again relief angle, very similar to the definition in our turning operations or main machining operations. It's actually the angle facing the machine surface. If you again keep it at 0, obviously you have too much friction, and that's why we need to again keep it around 5 to 10 degrees so that we don't rub actually the machine surfaces. And then maybe the most important part is actually this lip, this tip is doing the most of the machining operation. And we have an angle related to that. This angle is called as point angle. This overall angle is called as point angle. Depending on the type of drill you are using, it may be about 130 degrees or 120, 118, 100. Depends on, as I said, the application and the type of drill you are using. Then we have the drill diameter. This is actually the diameter we are going to open it on the workpiece. And now let's have a look at front view. As you see, we have many edges, some lengths, some regions, some margins, but you can see that we have a kind of a flat tip at the drill. We don't have such a sharp edge, right? Why don't we have that? Since once you have a sharper edge, probably it will be easily broken. Well, since you are applying force while you are doing drilling operation, that's why in order to increase the strength of this tip, the cutting edges, we have a kind of an edge here. This is called as chisel edge, and with the help of it, the strength of the cutting edges are improved. And the region responsible for cutting is actually called, this part is lens, and this portion is the web. We are not removing material. It's actually the beginning of the flutes, and this part is responsible for cutting operation. With the help of them, we remove material. We also remove material with the help of these edges, but not too much. The main cutting edges are at the tip of our drill, and we have some diameters, obviously, and but they're not important. The important ones are the chisel edge, the web region, the length. These are most important parts, terms related with the drills. Let me continue with some types of drills. The first one and the most popular one is called as twist drill. You can even machine most of the materials with it. You can see some typical angles, point angle about 120 degrees, relief angle about 10 degrees, some other angles, helix angle. Helix angle is quite important since it determines the strength of your tool. We will discuss it during the videos, but make sure that you know what these angles are referring to. And you see that there are different types of cutting tool materials. We start our discussion with twist drill, the most primitive type and maybe the most frequently used one. You see their diameters are ranging from little to very high diameters. And the thing is that their hole depth to diameter ratio is not too much. If your hole is a bit deeper one, if the diameter is too less, then it's better you use some gun drill type of cutting tools or drills. They are specially developed for actually opening deeper holes having less diameter. Now we'll discuss these in a moment, but this is the first one as I mentioned. And before discussing the other ones, spade drill, I will spend some time on this figure. You'll see that we have different types of drills, different types of drilling operations, actually, drilling and reaming operations. In the first one, it's simply drilling, nothing special. In the core drilling, actually, we need to start this core drilling operation by an available hole. Our aim is again to increase the size of this hole, but to very high amounts. We don't actually increase the diameter for about 2 millimeters, 3 millimeters. We are increasing it maybe with some centimeters. And then we have step drill tool. As you see, if you look at here, we have a kind of a step, but we have continuous fluids, and with the help of it, it might be using less force, less energy, since it starts with a less diameter and then increases diameter. So for difficult materials, it's better you use kind of a step drill. Then we have counter boring and counter sinking operations. These are performed on available holes. Their aim is actually to obtain a kind of an step here in the counter boring so that you can put your bolts into it. And counter sinking is similar to other one. The only difference is that this time you have tapered conical surfaces, and we use it for, especially for screws and some other type of joining elements. But the difference is that in the counter boring we have a kind of an stairs, but in counter sinking we have conical surfaces. And then in the reaming operation, we will discuss it in a moment, but reaming is for increasing the quality of your surfaces. You increase the surface quality and increase your dimensional accuracy with the help of reaming operation. As you see, we have special tools. We don't have such a conical, we don't have an helix angle. They're all straight. With the help of them, we remove less material but increase the quality of internal surfaces. And then we have center drilling. This is actually useful for determining the center of your hole. You don't actually start drilling first. What you do usually, you start center drilling and then do drilling, since with this one it's easier to mark the center of the hole. But if you start with drilling, then your drill might be walking on this surface. So this is called as walking phenomena, since we don't have a sharp cutting edge, sharp tip at the end of this drill. We have a chisel edge. It may be walking on your surface while you are doing machining. But if you start with a center drill tool, then it will be quite easier to find the center. And then once you have a little hole at the surface, you can then start drilling, since this time it will not be able to walk on your surface. And then lastly, we have gun drilling operation. It's especially used for deeper and smaller diameter holes. Its length to diameter ratio is very high, around 300, and that's why actually we need to use some special drills like gun drills so that you'll have highly accurate, deeper and smaller holes. This is another type of drill. After twister, we discussed twister. Now I will show you an example of spade drill. It is using, as you see, some kind of inserts. These blue ones are inserts, like in the case of drilling operation, turning operation, or milling. The advantage is that instead of, for instance, using this insert, you may change with a larger one. So with the help of it, the diameter of your hole will be larger, but you are using the same tool holder, so you'll spend less money on the overall tool, but you're only changing the tip of your drill. This will decrease your overall cost and improve your overall manufacturing efficiency. Let me jump to the other ones. Then we have gun drilling. As the name implies, this is actually useful for drilling deep holes or having length to diameter ratio around 300 or maybe even higher. The thing about these gun drills is that you need to have proper chip removal systems and proper coolant application, cutting coolant application systems. Otherwise, due to high temperatures, high heat generated, you may have problems. Then we have trepanning. Trepanning is quite special. Let me show you two types of trepanning tool here. As you see, with trepanning, we can machine large diameter holes. So this is opposed to gun drilling. In the gun drilling, our holes have larger depths. The depths are too much, but the diameter is low. But on the other hand, in trepanning, the depth is not too much, but the diameter is very high. So that's why actually we make use of some cutting edges at the tip of actually this circle. Assume that this is the circle we are going to open, and if you have some, let's say, 4 cutting edges like this one, then once you rotate this cutting tool on your surface, you will be opening a larger hole. But you cannot remove you cannot go too much deeper inside your workpiece. The thickness shouldn't be, as you see here, too much. Another application of trepanning, you may have a single cutting tool, but this time you need to center your trepanning tool and then later rotate this single point cutting tool around this center and again open a larger hole with less thickness. This is the main difference with respect to the other types of drilling operations. And I would like to talk about briefly on material removal rate in drilling operation. It's not complicated, and you can assume that we are removing again a kind of a disc in one revolution. So assume that this is the amount of material we are removing in one revolution. So this is our area. What is the volume of it? We can find the volume by simply multiplying with the feet. This time feet is actually into our workpiece, and I can show the feet in the side view. Actually, this is the feet, and we know that this is the amount actually we are removing in one revolution. So it's the volume of our material removed in one revolution, and that's why if you multiply with the number of revolutions per minute, we can obtain the overall material removal rate as we have done in the turning operation. And let's talk about briefly on thrust force and why it is important. The thrust force is actually acting on the, assume that if this is your drill, this part is drill, we'll have thrust force in this direction, okay? This is our FT, and if you have too much thrust force, then you may break your cutting tool from here, maybe here, and it will also do harm on your machine, on your tool holder, and that's why you should be careful about the amount of the thrust force, and it also affects the torque on your tool holder and the machine. So your machine should be able to withstand to these torques and be able to do the drilling operation. And we have some machines to perform such drilling operations. The primitive ones are called a drill press. This is the drill press, as you see, not so complicated. I can talk about some components of it. This is the column, and everything is actually mounted on the column and base. This is our base and column, and the rest is actually mounted on the column. So what do we have? We have a table. We mount our workpieces on this table, and as you see, we have some teeth slots, so we can easily have some workpiece holding devices, and then hold this workpiece properly, firmly. Otherwise, while you are starting drilling operation, you may have problems, since the workpiece should be stationary. Otherwise, you cannot have a relative motion between your tool and the workpiece. And this table can move over the column, and then we have the fixed head over the column, and then at the middle, at the intermediate part, we have this adjustable head, and this is actually moving with the help of this hand wheel. It moves and over the column, and with the help of this hand wheel, we can move it into the workpiece and move it out of the workpiece. And since we need to have a rotational motion over the drill, we need to have a kind of a spindle, and the power of the spindle is provided through this fixed column. We have a power head here, or probably we have some kind of pulleys, gearboxes. With the help of them, we can adjust the speed and then do the drilling operation. Now I will focus on some other types of drills. We have two more and three more actually. The first one is radial drills. The difference is that with respect to the drill presses that are, let's say, head is actually adjustable, head is rotating around this column. And another thing is that this head can move on this radial axis. So it gives you lots of flexibility. You can machine very large work pieces. If this is a table, actually, you can have this much of workpiece and open holes on any kind of region. And in the third type, in the universal type of drills, the main difference is that now we can rotate this drill head or adjustable head. This is the only difference in the universal head with this universal type of drills with respect to radial drills. And you have much more freedom, obviously. With the help of universal drill, you can even open some angled holes, but this is not possible with the radial drills. So these are the second type, third type, and lastly, we may have some gang drilling machines. In these machines, we have multiple spindles so that at a time you can machine many holes, and this obviously increases your productivity. In a shorter time, you will have work pieces composed of several holes. And this is another example, but the difference is that we have a turret here. You have different types of drills. So depending on the workpiece, depending on the hole, you may rotate this turret and have a different drill and open different size of holes. And obviously, work holding devices are quite important. As I said, we need to have a relative rotational motion between the workpiece and the cutting tool, the drill. If you cannot maintain it, then you'll have problems. Even you can do harm on yourself and may have some serious problems. Let me stop for now.